Hello, good morning students. So in the last video I gave you some assignment to do it by yourself. Now let's see how many of you got the right answers, and once again check if your answers are correct or not. So we'll start with the first one. It was find the total resistance between point A and B, and we had the resistances given as 5 ohms, 5 ohms, and when we move upwards 3 ohms, 7 ohms and 10 ohms. Now if you observe carefully, moving from point A towards B, let's say that the current was flowing from this way. So if the current starts flowing in this way and we come across at this point current splits up over here and here. So the one current flows in this direction and one current in this direction. Hence the resistances that come across in this and these two wires, they will be parallel to each other. So the 3 ohms resistor, it goes over here and the same current goes through 7 ohms. That means this 3 ohms and this 7 ohms, they are in series with each other. This 3 ohms and this 7 ohms, they are in series with each other, and these two in series, and this wire they are parallel, because once again the same current over here meets with this current and it comes total current over here. That means the current splits up in these two ends and then it combines over here, and therefore these two wires, they are in parallel with each other, which means that this 3 ohms and this 7 ohms, they are in series with each other, which are in parallel with this 10 ohm resistor. So we'll find the total resistance over here starting with this smaller point. Starting from that smaller point, we have, let's say that resistance R double dash, that is 3 ohms and 7 ohms, they are in series. So I'm going to write 3 plus 7, or if you are having confusion, you can name them, this one as R1, this one as R2, R3, R4, and this last one as R5. So you can remove the confusion by writing series, that is R2 plus R3, R2 plus R3, because we know the formula for series resistance. Finding the total resistance is the total sum. So in these two are in series, so R2 plus R3. So the total resistance that you get is 10 ohms. But we know that these two are in series and that is in parallel with this 10 ohms. So you can reduce the circuit for your simplicity purpose, and you can write like this. This over here 5 ohms, just for your understanding purpose, like this. So this is your 5 ohms resistor, that is R1, and over here you have now this new resistance, that is 10 ohm, that is your R double dash, and this one is 10 ohms as it is, that is your R4, and we have over here R5, that is 5 ohms resistors. This is R4 and this is your R double dash. Now this is how your new circuit looks like. Now this R double dash and R4 are in parallel with each other, because like I said, the current splits at this point and this point. So these two are in parallel. So I can write the new resistance R dash is equal to, this is in parallel. So we have to write 1 upon R dash is equal to 1 upon R double dash plus 1 upon R4, which can once again be written as 1 upon 10 plus 1 upon 10. Because R double dash is 10 and R4 is also 10. I hope you are getting this, because this is in parallel. We have to take the reciprocal of the total resistance. Once again, 1 upon R dash is equal to 1 plus 1 upon 10, because the denominators are same. So simple arithmetic addition of the, you can say, fraction numbers, and 1 plus 1 is 2 upon 10, which becomes 2 ones is 2 and 2 5s are 10. So this becomes 1 upon R dash is equal to 1 upon 5. Therefore R dash is 5 ohms. So now you have to do the reciprocal of this side, and therefore reciprocal of that also becomes 5 upon 1, which is 5 ohms. So you have calculated the whole mess over here, and your final circuit looks like this. So you have R1, which is 5 ohms, you have R dash, which is also 5 ohms, and you have R5, which is also 5 ohms. As you can see, from point A to B now, the whole circuit has been simplified. So this 1, 2 and 3, all of these 3 resistors are in series now. So what you get, the total resistance R is equal to R1 plus R dash plus R5, which is 5 ohms plus 5 ohms plus 5 ohms. So your total answer is now 15 ohms. I hope you understood this. Moving on to the next question, which was something like this. So the first one is 10 ohms, second one is 15 ohms, 20 ohms and then 5 ohms. Once again, for simplicity purpose, I will write all the resistances, R1 as 10 ohms, R2 as 15 ohms, R3 as 20 ohms and R4 as 5 ohms. You have all the resistances over here and you have been given the total potential difference, that is 45 volts. Question is, find the current flowing in the circuit. Simple. In order to find the total current, you will have to find the total resistance, because total potential difference is already given to you. So first find the total resistance, then using the total potential difference you can find the total current flowing in the circuit by using the Ohm's law. But once again, at this point, as you can see, the current splits up in these two wires, and therefore these two resistances are in series and these two resistances are in series, but the total of this resistance and the total of this resistance are parallel because they are in two different wires, because that same current then matches over here to this point. So that is why these two resistances are in parallel to each other. But to find the total resistance, first you need to find the total resistance of these two resistors and then these two resistors. So finding the total resistance, R dash, I am writing R1 plus R2, because these two are in series, same current which divides over here flows in 10 ohms and then in 15 ohms. So this becomes 10 plus 15 is equal to 25 ohms. Next, in the same way, I am writing R double dash as R3 plus R4. Once again, 20 plus 5 ohms, I get the answer as 25 ohms. I hope you are getting this. 20 plus 5 ohms, you get 25 ohms. I hope it is clear to you. Finding the total resistance of the circuit. Now this becomes 1 upon R, because these two are in parallel now. If I solve the circuit over here for your simplicity purpose, what I get over here, it is like this. I have 45 volts over here, and then over here what we get is 25 ohms, and this is also 25 ohms. We have simplified the circuit. Okay, moving forward, we get 1 upon R is equal to 1 upon R dash plus 1 upon R double dash. Therefore 1 upon R is equal to 1 upon 25 plus 1 upon 25, which becomes 2 upon 25. Therefore total resistance R is equal to 25 by 2, because 1 upon R we are doing reciprocal of it. 1 upon R we are doing reciprocal. In the same way, 25 upon 2 we are also doing reciprocal. So R becomes 25 upon 2, and you get the final resistance as 12.5 ohms. So the total resistance that you get is 12.5 ohms. Is it clear? Understood, everyone? Okay. Now we need to find the total current flowing in the circuit. So we apply the Ohm's law. Ohm's law, V is equal to I R. Right? Potential difference is given as 45 volts. Current you need to find. Total resistance R is 12.5 ohms. It is 12.5 ohms. So in order to find the current, I will have to cross multiply, which becomes 45 upon 12.5 ohms is equal to total current I. So I can write over here, therefore I is equal to 45 upon 12.5. Now You can go with two approaches. You can directly solve like this, or if you want to simplify it, you can multiply by 10 and divide it by 10. So what you get is 450 upon 125. In order to remove the decimal points, you can do this, and then you can solve further. Now because this number is quite huge, you can use the smaller numbers in order to simplify the fraction, like we used to do in smaller standards. So this is 450 upon 125, 0 and 5, so you can use 5 to cut it. So what you get is 5 nines are 45 and 0, 5 twos are 10, and you get 2 over here. So 5 fives are 25. Once again, 5 fives are 25. What you get over here, 5 ones are 5 1 is 1, 5 1 is 1, you get 4, 5 8, you get 40. So the final number that you get is 18 upon 5. Now obviously we are not in smaller classes, so we will simplify it even further. 5 1 is 1, 5, 5 threes are 15, remaining 3, 5 6 are 30. So the final answer that you get is 3.6 amperes, and this is how you solve the whole numerical. I will keep it over here. You can pause the video and then you can check the whole answer. Okay, we'll move forward with the final numerical that I gave as the homework to you, and this is it. Once again, the question is the same. Find the total resistance and the current flowing in the circuit. If you remember, find the total current flowing in the circuit. I gave you the homework, and this is it. So we have 4 ohms, 3 ohms, 3 ohms and 3 ohms over here, 7 ohms, and the battery connected is 9 volts. Once again, you can see when the current flows from here, you can see it gets divided into 3 points, 1, 2 and 3, and then once again it meets from these 3 points. So this 3 ohms, this 3 ohms and this 3 ohms, they are all in parallel over here. So first of all, I will solve this part and then I will continue forward. So when I solve this, I get 1 upon r dash is equal to 1 upon 3 plus 1 upon 3 plus 1 upon 3. As you can see, all the denominators are same, so no need to do this. So 1 plus 1 plus 1 upon 3, I get finally 3 upon 3. So the final answer is 1 upon r dash is 1 upon 1, or I can write r dash is equal to 1 ohm. Now what happened over here is 1 upon 1 is 1, and it doesn't matter even if I take the reciprocal, it is still 1. So the total resistance of these three parallel resistors over here, each of 3 ohms, we get the answer as 1 ohm. So the circuit has been simplified. Once you see like this is 4 ohms now, this is 1 ohm, and this is 7 ohm. So I removed all the 3 resistors, and their total resistance, which is 1 ohm, I made a drawing of it over here. So then it becomes one single resistor in the whole circuit. This is for simplification purpose. You don't have to do this again and again in your answer sheets whenever this type of questions are asked in the exam. Okay, you simply have to understand the circuit and solve accordingly. Or if you are confused, you can do that in the rough work, but there is no need to do it in the fair copy. So this is 9 volts. This is your final circuit. Now as you can see, this is quite simple. We have 3 resistors. Simple, these 3 resistors are in series, so we get the total resistance R is equal to 4 ohms. Total resistance R is equal to 4 ohms plus 1 ohm plus 7 ohm. 4 plus 1 is 5, 5 plus 7 is 12. So we get the total resistance R as 12 ohms. Get it? So total resistance R is 12 ohms. Once again, we apply the formula for Ohm's law in order to find the total current flowing. So V is equal to I R, that is V is given as 9 volts, current I you need to find, resistance is 12 ohms. what we get over here is current I is equal to 12 in the denominator, so it becomes 9 upon 12, 9 upon 12, so it becomes 3 3s are 9, 3 4s are 12, so we get I is equal to 3 upon 4, okay, or I can write it as 0.75 amperes, because when I solve this, 4 1 is 4 and 4 0.47s are 28, 2 is remaining, 4 5 is 20. So what you get, the final answer, current I flowing in the circuit is 0.75 amperes. I hope you understood all the 3 questions. I repeat for you once again what we had done. I gave you these 3 questions for the homework. Revise it once again. These 3 resistances, these 2 in series, 1 in parallel, so you get 10 ohms, and then these 2 are in parallel, so we solve them. 1 upon 10 plus 1 upon 10, you get the final answer as 5 ohms. Once that is done, you have these three resistors that remain in series. Simple addition of them gives us the total resistance, that is 15 ohms. In the second question, it was much more easier. These 2 they are in series and these 2 they are in series, so we solve them. So 10 plus 15, so 10 plus 15 we get 25, and this 2, that is 20 and 5, we get 25. But these two, so these 2 they are in parallel with each other, so we get 1 upon 25 plus 1 upon 25, which becomes 2 upon 25, and because this is a parallel one, we take the reciprocal of it, so it becomes R is equal to 25 upon 2, which becomes 12.5 ohms. Now all that remains is finding the total current flowing. So we give the value of 45 volts, that is the battery or the cell given to you, I, and 12.5, simple cross multiplication. Current I is equal to 45 upon 12.5. Removing the decimal points, you get 450 upon 125. Solving it, you get the answer is 3.6 amperes. The last one that I gave you was this one. So these 3 are in parallel, 1 upon 3 plus 1 upon 3 plus 1 upon 3. Simple 3 by 3. So R is equal to, what you get is 1 ohms, and final circuit looks like this because the simplification of all these 3 is simple 1 ohm. Simple addition because they are in series, so 4 plus 1 plus 7 gives us 12 ohms. Again applying the Ohm's law, V is equal to IR, 9 is equal to I into 12. Solving them, we get the answer 0.75 amperes. Okay students, we'll stop here for today. We'll talk about the next topic in the new video.